We'll be talking about a tool that we open source for the bug bounty community called ReproNow. It will help you save time, reproduce, and triage security bugs. Quick introduction about ourselves. I'm Vinay Nataraja. I work for the product security team at Salesforce. I help build secure products, and I also lead their bug bounty efforts.
Hi, everyone. Is this on? Yeah. Hi, everyone. I'm Lakshmi Sudhir. So I work as a product security engineer at Adobe, and I help build all secure products and make sure we are shipping everything, and we have a security review before that. So let's get right into the talk today. The agenda for today is we are going to just start with a brief introduction to the bug bounty program. How many of you work on bug bounty programs or are aware of it? Okay, that's a lot of you. So it's just a very small, brief introduction, I promise. Then we're going to walk you through the triaging process. So the triaging process involves from what happens from when a researcher submits a bug to a security engineer validating it, reproducing it, then assigning a severity, and finally logging an internal ticket in his ticketing system. So that's the triaging process. Then we are going to walk you through what does our tool, ReproNow, help with? How can it help you with the triaging process? Then we get into the technical details of how we build this tool and what are the libraries we use and more on that. And if the demo gods are kind to us, we are going to have a successful demo. Then we're going to talk about some of the future plans. So we are trying to leverage the most out of this tool and maybe feed it to the other tools and make it a full-formed product out there. So that's something we're going to discuss in the final part of our presentation today. So let's get into bug bounty programs. So what's a bug bounty program? It's nothing but crowdsourcing security. So companies have a structured program and they expose their application for researchers all over the world to take a look at it and responsibly disclose security bugs. Then the company validates it and it assigns the risks based on the severity to what it means to that particular company. They pay out for valid bugs. So this way, it's a win-win situation for both because as a company, you cannot hire like thousands of those researchers who you have access to through this bug bounty platform as a full-time employee. So the company gets really good bugs. They have so many eyes on their application, while the researcher also gets what he wants. He can have bragging rights. There are so many people who made a name in the security community through the bug bounty platform. And I've also met a couple of researchers who do this as a full-time job because they get paid, and it's a pretty good place to even brush up your skills. As a student, I myself worked on bug bounty programs to improve and understand how the real application security looks like and how I could improve myself there. So this is what is the bug bounty program in a nutshell. So let's say your company wants to start its own bug bounty program. How do you start off with it? So you need to have a structured approach. The main part of the bug bounty program is to build a page which has the scope, that is the product you're comfortable exposing to the researchers. You wouldn't want that to be your first line of security. So probably it's a mature product which already has some security reviews and internal pen testing. You specify what product are you comfortable with the researchers taking a look into. Then you define what are the do's and don'ts. This is a very important column because you need to specify what bugs are you looking for or what exactly are you looking for from the researchers. You may want to exclude things like denial of service because you wouldn't want a researcher saying, hey guys, your prod servers are like susceptible to denial of service. I mean, that's the last thing we want. That's a nightmare. And you may want to also add something as simple as, let's say there's some best practices that you're in the process of implementing. Let's say a content security policy, for example, you have it in the going and you don't want a researcher saying, hey, you don't have these security headers because that creates a lot of noise in the program. And you could also define that I may want you to look into this new API we've built, and this is exactly something that we are interested in. And there are companies which also offer promotions on certain new features they want to be tested by researchers. So that's how you start with. Then you set up credentials and accounts for all the researchers so that they could log in and go ahead testing the system. Then the researchers, they submit the bug which needs to be validated and fixed. So there'll be a security engineer on call who looks into these bugs and validates it and reproduces it. Then the company pays bounty based on the severity after the bug is resolved. So this would be the setup for an organization when they start off with. And let's see what happens when a researcher submits a bug. So the researcher submits a bug, all good so far. Then the security engineer triages it. Now this triaging process is what starts off where the security engineer reads through the report, he understands it, then he tries to reproduce it on his end and validates it, assigns the severity, and creates an internal ticket in his ticketing system, could be Jira or anything that they use for the company. This whole process constitutes triaging. Then the company resolves the bug, all good, and the researcher is awarded bounty. Well, this is an ideal scenario. It never occurs, and this is just the expectation how a smooth flow should be for a bug bounty program. But let's look at what happens in reality. In reality, the researcher submits a bug, still great. Then the security engineer tries to triage this, but he requires more info to reproduce the bug. I mean, we live in a complex ecosystem out here, and it's pretty hard to have all the information in a single report, like it was discussed in the previous talk here as well. So he says that, okay, I'm not able to triage this. Could you please provide me with more information? At this point, the researcher provides probably some post requests and some screenshots maybe, and he's like, all right, take this information. Maybe this will help you reproduce it. And then we think it should be triaged, but no. The security engineer is like, all right, I'm not able to get this because there's so many preconditions to most of the bugs that we have. It's pretty complex out there. Then maybe the researcher provides a video of the vulnerability and the security engineer still hasn't been able to triage this. And it's a vicious cycle. It takes a lot of back and forth with researchers to get to a point where you can reproduce this bug. And this is actually the reality of it. And so let's look at a list of, this is not an exhaustive list. To begin with, what information would a security engineer require to triage? Of course, he needs to know what product is the vulnerability on, what is the URL, what is the description, what are the steps exactly to reproduce and the pre-existing conditions for this bug to occur. And he may also require some of the request, response, or probably a video walkthrough of what all happened and what was the complete process. And maybe that bug occurs only when you do step 1, step 2, and then step 5, and then step 4, or something like that. So you need all of this information and way, way more than this. So this is pretty much the list, a simple, like the major list of what all a security engineer needs to triage. So we pulled out some of the reports from HackerOne, which is a bug bounty platform, and these are all real reports submitted by researchers to actual companies. So let's go through the first one. So here, the researcher has submitted a bug with a lot of steps to reproducing. There's probably some vulnerability at a particular endpoint. Now the security engineer looks at it, he's like, oh, I think this was probably fixed with another report. Could you please confirm? At this point, the researcher goes back and again tries to again reproduces that bug to see if it still exists. And he's like, no, this hasn't happened, but do you want to try it with my account ID? So there's another piece of information the researcher is providing. Then the security engineer still tries it, and he still couldn't. So at this point, just with these many interactions, and we have taken off some of the interactions in between, they've at least reproduced it 3 times, one from the researcher and from the security engineer. And there's so much time lost out there. And finally, the researcher submits the video and provides some more information, and then the bug moves to triage. This is the amount of back and forth that takes place with the report. Let's look at another report here. Okay, so yeah, here the researcher submits a bug saying there's some bypass of 2-factor authorization. And then it moves, the security engineer takes a look at it, and there was some more steps to reproduce out there. He says that it's not applicable. Not applicable means the company does not find value in this bug, and we are probably never going to look at it. It's really not applicable to a program. Then the researcher has a lot of back and forth going, but this is one of the last snippet of conversation he has. He's like, I'm super disappointed with this because he's lost his patience trying to explain this whole bug. And this happens a lot of times. Well, no one is at fault here. It's pretty hard because of all the issues we face with triaging and just to report explaining a complex bug. And finally, he gives a final level of steps to reproduce and a lot of information out there. And then this bug moves to triage. It went from submitted, not applicable, to triaged. So even if one of them, the security engineer or the researcher, had lost their patience out here, the company would have lost a bug and also a researcher, and the researcher would have lost interest in the program, or for all you know, in the whole bug bounty concept itself. So sometimes we also, on a lighter note, we get some reports like this where it's like, oh, I paste my cookies to another browser and it still works. I mean, you wouldn't want to go about explaining how web works to everyone. So there are times when you have some of these spam reports, and weeding this out also is a part of a security engineer's job when he's managing a bug bounty platform. So let's get them all together. What are the issues with triaging? The biggest in bold is communication issues. Since bug bounty is actually crowdsourcing security, you have a lot of people from different geographical locations. And I understand English, and they may be amazing at French and finding great vulnerabilities, but this process of explaining that bug to me is pretty hard. So this is one of the major issues that we deal with. Second thing could be a knowledge gap of product. I mean, each product has its own reasons to probably not have some of the security best practices because of functional needs. Sometimes functional needs take over certain security aspects, and and you accept the risk. So this also causes a lot of people probably saying, oh, you don't have extreme options, and probably your whole concept of your product is to be iframed or things like that. So that's one of the very common issues we have. Also, out of everyone, should agree that not everyone can actually write a good report. Finding a bug is something, and writing a report and explaining it is yet another thing. We live in a complex world today. You have microservices, you have applications, you have so many interactions across so many components out there, and obviously the bugs are complex. So explaining all of this in just a report, it is pretty cumbersome, and it's almost borderline impossible. That's one of the issues. And speaking of long reports, we've got a lot of long reports where researchers really make a lot of effort, put a lot of effort into finding the bugs and explaining the entire thing. But it's taken us 6 to 7 years to just triage that and reproduce it, reading through the whole long report. Again, the time spent is a lot out here. And like we saw the previous report out there, there are a lot of wannabe hackers. So they might just fling some spam onto these programs. And sometimes you may probably not even use Apache, and they're like, oh, this version really, you have to update your version and stuff. They just try to like throw away a lot of bugs to different programs and be like, hit or miss, probably we're going to make money. So weeding out this also is one of the issues we face. So what are the bug bounty pains for companies? Time spent, the biggest one. Each engineer, all of your security engineers are sitting there reproducing bugs that we've already received, and that loses a lot of value of having a bug bounty program. If a security engineer has to spend like hours together just triaging, reproducing, going back and forth, that's not the best use of time for any company or any security engineer out there. So that's one of the major pains for companies with respect to these bug bounty programs, which is reduced efficiency all over again. So average resolution time is the amount of time taken by a company to resolve a bug from when it was submitted to the time it was triaged and finally resolved. So this plays a very important role as a metric with bug bounty programs. So as a researcher, if I'm looking for companies to like take a look into a hack and find security bugs, I would look into this average resolution time. So the more it is, the more the researcher is not really interested. The shorter time is more attractive as a researcher because I've spent so much time and I might as well get my bounty sooner and it gets resolved. So that's one of the issues that we'll face because of longer triaging time. The researcher relationship again and the retention part of it again falls back to the average resolution time. Also, if the researcher loses patience, he's like, oh, they never understand me, they never get my point, he's not going to stay in the program. So these are the bug bounty pains for companies. And this quote by Colin Green of Facebook pretty much explains what I was trying to say. Triage takes so much time. And so much time that each company has about 2 or 3 full-time employees just managing this platform. And this is exactly what we are trying to solve and help in a way with ReproNow. So what is ReproNow? When I will take you from here.
Thanks a lot, Lakshmi. So ReproNow is a browser extension that we have built, which captures the desktop and the network, and then replace it, and you can view it in a responsive UI, which maybe your security researcher or the security engineer can go through and triage it. So this browser extension has one really good feature is that when you record the network, we hide the network traffic inside the video file itself, such that you can play it in a VLC player and works fine. We're going to dig in more about this in the future slides. It works cross-browser. It uses the extensibility API, so that's supported by most of the browsers. Currently, it's supported by Chrome and Opera. We have other browsers in the pipeline. One important thing when you're a security researcher is that when you find a bug, it's maybe $1 million bug, you don't want to share it with any server or any vendor. That's one thing that we did note, and we made sure that everything, whatever happens on the client side, and the data or the request itself doesn't go to the cloud. The requests that you make can be exported as curl, and then maybe you can put in a report as well. So we have functionality for that. We save the history of the recorded videos in your history. So if you want to go back to a particular report and look at what happened maybe 3 weeks from now, you can do that as well. I'm going to talk about the multiple options for capture network in the few slides. And best of all, this open source. I know I'm paranoid about installing anything on my Chrome. So it is open, so you can go look at the code, and if you want to add more function to it, you feel free to do so. So let's look at the technical aspects of how this tool is built. There are 3 main aspects to it. There's the screen capture, which uses user got Now, get user media API, there's the network capture, which is a web request API, and there's the network capture, hiding the network capture inside the video file, which we use MKV files. So let's look at the screen capture part of it. So for screen capture, if you want to capture screen in a browser, the go-to method, the HTML5 API is get user media API. Chrome has a special API for extensions called Chrome.desktop.capture API, which you could use, which in turn uses get media API. And then the get user media API basically can capture your camera, mic, and also screen. In our case, we just capture the screen. The results of which is fed to the media recorder API, which then converts it to an array buffer. The media recorder API has supports for multiple containers and multiple codecs. In our case, we are using WebM, and this is some of the codecs and some of the containers that it supports. We are using WebM, and we are using VP8 for the codec. The array buffer that comes out of the media recorder API, we then convert it to an URL using the create object URL API, which is then piped to a video tag where you can see the preview. Let's look at the code snippet for the screen capture. So as I told, we use the Chrome.desktop.capture API. We then pass in a bunch of parameters and then have a callback function, which is on access approved. The callback function we use is get user media API, has a bunch of parameters, which is the desktop, it's capturing the desktop, it's capturing the screen, and it's telling what's the width of the screen and what's the width or height of the screen. And then it has a callback function called gotstream. The callback function gotstream, of course, has a stream. We set it as a global variable, and then we pass that variable to the media recorder, which is media recorder API, and then that has a callback function on data available, which has the array, which we store it, and then pipe it to a URL, which is then piped to a video tag. So this is how code for screen capture looks. Let's look at network capture. So if you want to build an extension and you want to have network capture, you have two possible ways of doing this. You can use the Chrome.debugger API or the Chrome.webRequest API. Chrome.debugger API is really good because you can attach a debugger and intercept traffic. The only problem with the debugger API is that it puts all the tabs in a debugger mode. That means you're going to see a big bar at the top telling it's in debugger mode, which is not exactly good because we are capturing the screen as well. So the second option is Chrome.webRequest API, which lets you observe, analyze, intercept, and also modify requests in flight. We don't need to modify, we're just analyzing it and just logging it. The only problem with the web request API is that it doesn't get the response body, which is fine for us because we're just concerned with the request part of it, the request body, cookie, and the headers. So we went with the web request API. Digging in more about the web request API, there are a bunch of methods that it supported. We're not going to dig into each one of these, but these three methods are for the request side of the communication. And for the response side, the first four methods, the last two is when the communication is completed or if there's any error that happened. For our tool, we use these three methods. This is on before request to log the URL method and the request body, on before send headers to log the headers before it sends to the server, and then when the communication receives back, we log the headers from the response. One more thing that we do to kind of sync the screen and the network is kind of start a clock as soon as the screen capture starts and the network capture starts so that we can sync both the screen and the network and show it in our previewer. And also for network capture, we give you multiple options. You can capture the network for only a specific tab or capture networks for all the tabs that are open in a window. Or you could, let's say you have 10 tabs open and you go from tab 1 to tab 2 to tab 3. You should capture the network only to the navigated tabs, you can do that. Or if you want to capture it to the most active tab, you went from tab 1 to tab 2 to tab 3, but only the active most tabs should be capturing network, you can do so as well. We are given more explanation in our GitHub page, so if you have any concerns of how exactly it works, you can go there. So let's look at the code for network capture. The network capture basically is the Chrome web request API. It has a method called on before request. We attach an event listener to it and have a callback functions and also add a bunch of parameters to it. The callback function will have the details of it and we just log it in a JSON blob, which we then use it for regenerating the network. So we have captured the screen, we have captured the network. Now there's a more important aspect of how do we share this with someone else. Lakshmi is going to talk more about this.
Thanks, Vinay. So we have the screen as a video right now and the network as a JSON. And one of the requirement we had was, not the requirement. First of all, we thought that we could just download two separate files. And if you want to watch them together, you can just upload it on a previewer as a JSON file and the video, and you can watch them in tandem. But then we thought it's a pretty cumbersome thing. Probably we'll zip it up, just being lazy. But again, the same thing stays because you'll have two different files. So we thought, why not insert this network file inside the video? But one of our major requirement was everything should stay on the client side because that's the whole principle behind building our tool. And also that if you just want to watch the screen data, just the screen capture out there, it should still play in a VLC media player or any third-party player. So that was our major concern for sharing screen and network together. So we went ahead and we were like, okay, let's look at how we can do this. So the major need out here is a video format which supports adding a JSON file without breaking the video, such that it still plays in other media players. And then we also had to find some tool or a framework that could work on the client side to manipulate this whole video thing, because we need to store the network data when a researcher is downloading it. And when you upload it, we still need to dump it and put it on our previewer. So this was our major need. Let's get into the first part of finding a video format. So we explored a lot of video formats like MP4, MKV, AVI, FLV, and 1,000 others. But today, for the scope of this talk, we're just going to get into MP4 and MKV. To start with, MP4. This is one of the most commonly used digital multimedia format container. So this stores audios, videos, everything a digital format container should do, pretty much. One of the caveats was it wasn't open source. Then we looked into the structure of this. It has the file type. It has three major parts. One is the file type, which is MP4, obviously, in this case. And then we have the metadata container, which contains tracks, subtitles, author, URL, all the required metadata. And the multiplex data stream is where the actual audio and video frames are stored. So we understood that if we do any manipulations, it should just get into the metadata container. But that not being open source, we did not get much information about it. That's when we were like, okay, let's look at MKV. So the best part about MKV is it's open source. There's a lot of information available about it. And it's a free container format. It holds unlimited audio, video, and yes, files, tracks, and subtracks, and all of those. So we found this really nice. Then we also saw that WebM is derived out of MKV, and it was specifically built as a video format such that it can be supported across the web, which is exactly what we are looking for. We want something that can work on the browser side. So we looked into its file structure. So header contains the EBML version, which is MKV, and then the metaseq information, it indexes to the rest of the complete structure of MKV. Then there are clusters where you have the actual video and audio frames. And the main thing that we've been pointing at clearly was, the obvious thing was attachment. So the attachment section allowed any file type, like any file type. It did not have restrictions on that. We had to do was specify the file type and give the file data. And this was exactly what we were looking for. So MKV was our best choice to choose a video format that could hold both the network data and the screen capture as well. So we also found out that WebM and MKV can be used interchangeably, and most browsers support either WebM or MKV or both. So either way, we were covered on all sites with this. And further, as we went on, we also found that it's easier to store and dump a JSON file. We'll get to it in the next slide. So MKV was our chosen video format, which satisfies our need one. The second one was a tool or API, something to perform client-side operations to manipulate this. That is, to attach this JSON file and then dump the JSON file. So for this, the first obvious choice was FFmpeg, which is the mother of all multimedia framework manipulations. It encodes, demuxes, muxes, it does everything. It supports a lot of codecs. So this was a pretty obvious choice for us. But again, we had to find something on the client side, and we came across ffmpeg.js, and we used this to actually attach the network data, that is JSON, into our MKV file. And this is a server-side code snippet which we've attached. All you do on the server side, but we implemented this on the client side. So on the server side, you just give the input, which is the screen data in the form of video MKV. Then you attach the JSON data, which has all the network data out there. And then you specify the MIME type, and there you have the output with the JSON inside the video without breaking the video. So this was the best solution we came up with, but then we found that it's a little slower than what we would hope it was. That's when we came across TSEBML, which is a Node.js library. It performs the same thing, but it supports lesser codecs and stuff. So we have used both. We first go to TSEBML, and we let that attach the network data to the screen data out here. And in case that doesn't work, we have a fallback of an ffmpeg.js. Either way, you have a reliable way of having your network data and screen data together. So to put them all together, we are recording the screen using the Get User Media API. Then we capture the network using the Web Request API and store it as a JSON. Then we save the video and JSON in your local storage. Nothing gets on the server. Then you preview the video using the video tag. Then we sync the network with screen so that you know where exactly, whenever you're, let's say, clicking a submit, you know what exact request went down there. And then when you download the video, to share it, let's say, with a security engineer, you have the network data as well within the video. So you put it on the previewer, you have the video and the network data. You just want to watch the screen capture on VLC or any other player, it still works. So to see how all of this works together, Vinay is going to walk you through the demo.
No, you hold this. Okay, so let's do a quick demo. I'll go to the most secure site in the world, demo.testfire.net. Is it connected?
Yeah.
It's connected. Okay, so let's say I'm a security researcher. I'm trying to find an SQL injection, and I want to report it to testfire.net. So this is our Chrome extension. As you can see, there's a start recording button, which will, of course, start recording. There's a name. So let me type AppSec demo. And then the network options that we talked about. There's a history tab, which will show the recorded history for any of the recordings you have. And there's a previewer. If you already have a recording and you want to upload it, you can do that. So let me go and start the recording. And I want to find an SQL injection somewhere. Let me try to navigate to some of the pages and check if there's an SQL injection. Nothing here. Let's go to the feedback tab. Looks interesting, maybe, maybe not. Let's go to the sign-in page. Yeah, this looks good. Let me try injection payload, give a dummy password, and it's taking its time. Okay, so yeah, it gave an SQL error. So I think there's an SQL injection in this particular website. I'm going to report it, so I'm going to stop my recording. So as you can see, as soon as I started, as I stopped, the previewer popped up. There's a video on the left-hand side, the network interactions on the right-hand side, and there's a request and the response on the bottom. So I can go and play the video, and it starts off going through the network on the right side. So as soon as you click, the network interaction comes through, and basically it follows you as soon as the video goes. Let's say I will want to look at one particular request. I can just pause the video, go to that particular request. It automatically takes me to the video and also shows me what request and what's the header and what's the cookie and the body of it. This was a payload that we submitted, and this was the cookies that were passed, these were the headers. Okay, I think this looks good. I'm going to download it. Now, let's say I want to share this with the security engineer to kind of report this bug. So the security engineer has many options to kind of look at the video itself. One is, of course, installing the extension, going to the previewer, or he could go to our GitHub page, download it in his client side, and run it up in his local storage, or you can go to the website, and we have a version of a previewer running there. So this is a previewer. I'll go and upload the video I just downloaded. Oh yeah, before that, I'm going to open this video in a VLC player and make sure that it works fine. It does work fine in a VLC player without breaking. So let me go and upload the video that we just demoed. And you can see all the network interactions are back for the security researcher. Let's say I know what the payload is. I'm going to just search for the payload directly, 1 = 1. And it takes me directly to the network interaction which has the payload. And then you have everything else. Let's assume you're on burp and you want to test it. I want to move this to burp. There's a curl scriptlet, so you can just click on the curl request, go to your terminal, paste the curl. I want to proxy this to burp. Okay, so I'm going to proxy this to burp, -x 127.0.0.1, port 8080. And -k, ignore all certificate warnings. It's going to take some time, I guess. It's taking more time than expected. Yep, it's come through. I think it's taking, this one is taking some more time. It's come to verb. Now I can send this to the repeater and continue my testing in verb. So yeah, this is a quick demo of our tool. Let's go back to the slides. So how is this useful for bug bounty hunters? First of all, it's an awesome screen capture tool. You could preview your capture before sharing with the reporter, sharing it with the company that you reported in. And also you could ability to copy paste raw requests and responses. Let's say you found a bug, you want to copy paste a particular request, you can do that. And also you can generate curl requests easily using this tool. Instead of writing a long report and explaining everything, it's better to have a video with the network interactions. It's easier not only for you when you're generating it, but also for the person who's triaging it, because since he knows the application, he can directly go to a particular URL and find out what went wrong. As I told, we did not want to kind of trust any cloud out there. We wanted to keep everything in the client side, so you do not need to trust a vendor, and it's open source, so you're free to look at the code and also add your own functionality to it. If you could help your security engineers to triage faster, that means you're going to get bounty faster, which is good. For organizations, this is really useful because you don't have to manually go through the steps and reproduce it. Since you have the network request, you kind of know what's happening, and directly you can go to the particular endpoint and check what went wrong. It helps reduce noise. If you could kind of use this as a gating mechanism, you can kind of know if a person is submitting a bug which is spam, or is it a real bug. It helps save your security engineers time. That's kind of the main reason we built this tool. It also saves money because you don't have to invest in managed services. You can just kind of help make sure that your researchers use this tool, and that way you can reproduce the bug faster. We built this tool for security and the bug bounty in mind, but also it can be used for QA. When we open sourced it, there were few companies who are interested in QA as well, and even internally at Salesforce, some of the teams are using it for QA, which is great. If you could triage faster and pay bounty faster, the researcher is going to come back and is going to submit more bugs, maybe better bugs, which is great. So what are the future plans? One thing that we want to do is use this tool to automatically triage. Since we all have the network request, we just have to replay it, and then we can kind of know if the bug is valid or not. Also, I know that most of the security researchers do have access to only the production instance and do not have access to staging or maybe a QA instance. So if you have this network interaction and you want to test it if the bug has been fixed after the developer has fixed it, you could kind of replay the same network in your QA instance or your own staging instance and find out if the bug is valid or not. And also you could replay it in multiple browsers and check if it works in other browsers as well. One thing I think most companies do is automatically run some kind of ZAP or maybe burp automatically for each of your internal systems. The main problem with burp or ZAP is that it's very difficult to find the login if you give the username and password. Or if you have something like an OAuth, that way it can't detect if you are logged in or not. ReproNow can help with that. Since it's going to capture all the network, you can replay all the network and make sure that result is fed to ZAP, and you can have automated scans. That's pretty much it. If you want to check out the code, it's in the GitHub page. Chrome extension, if you want to play around, it's in the website and /Chrome. Thank you, and we're open for questions.
I can pass them. Okay.
Great presentation, thank you. It's not working. Anyway, I had two questions.
Yep.
So the first one was the thing you talked about, the automated login detection. That's still not automated detection, right? You're saying that we'll replay a manual login detection, so
yeah, you just have to capture it once, and then you have the network request. You can just replay that in your old browser, so you don't have to manually get the cookie and put it in your.
Got it. Okay. And then the other question was, you said it wasn't like none of it was server side, but like when you're talking about the website, requires me to go upload the,
No. So there is basically, if you go to ReproNow, the website, if you go to code, you can download a version of it and play it in your local host.
oh, okay, so you're deploying kind of the website
We
yourself?
just kept
Yeah.
it out there as if someone wants to use our website, that's it.
Okay.
But you don't need our website at all.
All right,
Thank
thank you.
Any other questions?
This is really cool.
Thank
As a developer, I think giving this to my users is a great idea. One item I had kind of just like a question about. First off, did you say that you know of somebody who submitted $1 million bug?
I've read blogs about
Yeah,
it.
okay, that's pretty awesome. But more so, what about intrusion detection and exploits that don't use the browser? And when the researchers, I like how you call hackers researchers, want to communicate the methods that they use to kind of penetrate your system, have you guys put any thought into this type of tool that would just capture the desktop?
Yeah, for sure. I mean, right now it works as a Chrome extension. I'm not really sure if Chrome allows you to capture the network of the system itself. Yeah.
Yeah, no, his question was, do you have a desktop application, like something that captures the network side of things, right? Not yet. This does not capture the network side of things. Like, I mean, you're talking about the whole system per se. Sure. So not really. Right now it works on the web application. We don't have anything planned, I guess. Do you have anything planned? I don't know. So yeah.
It would be great if like a fiddler
Yes.
and a recording happening.
Yeah, I think that's a good feedback. I think we're going to think about that. Maybe that's a good idea.
Yeah.
Thank you, Ro.
So some of the bug bounty platforms are integrating ways to do teams as far as hunting goes. Do you guys have any plans to extend this to a team of bounty hunters wanting to share information as far as their, one person works on one part of an exploit and the other one works on another part, and then you can combine them and work together inside of kind of a framework like this?
So you mean to say like, if one person works on it and then you combine both the network requests together and then show it as a different video? Right now it doesn't, but we have certain things like that. For example, one thing we thought was, what if there is 2 different browsers involved and you need to kind of have maybe like a privilege escalation of one user to another user. So we have put a thought of it, maybe we can combine both of them together. But yeah, we still have to figure out how to do that. We're still kind of brainstorming on that.
Hi. My question is like, if I want to compare with Wireshark, like, capturing all the network traffic and SSL sessions and everything, how different it is other than being a video?
Wireshark will capture the whole network of everything in your, whatever is in the scope. This captures only the browser interactions that you do. Other than that, it's kind of similar, but Wireshark will give you more granular things of what's exactly happening. This is on the application layer, just the GET request and the POST request.
It's like replicating what really happened when they're trying to
Exactly.
Exactly. So we have
Got it.
designed it for web apps, mostly.
Visual, like, got it.
Yep.
Okay, thank you.
Hello, thank you. I was curious if you guys built something out of Selenium before this, and if this is a second version of it, or how is it different from just a Selenium script that replays a series of requests and response?
Yeah, we kind of built this for Chrome, the browser itself. Selenium script is kind of different because you need to have your own thing that is running and it captures everything. This is mostly for bug bounty. That's the whole target of it. It's easier for them to have it, and it's easier for us to reproduce it. That's kind of main thing. But we have kind of looked at how we can feed this information to Selenium itself so that it can automatically triage. But yeah, that's something that we want to build.
Yeah, we have this thing where, after a bug is once fixed, it gets also sent to the QA team so that they can put it on their QA automation so that it never pops up again.
Yeah.
So that's an excellent
Yep. That'd be
addition to this.
Yeah, exactly. That's what we thought. That'd be really useful for the QA team to kind of make sure that they run this as soon as they build something. That'd be great.
Thank you so much.
Any favorite feedback from heavy users of this so far from the bug bounty community?
One thing that one of the users asked was have JavaScript logs as well with the network interaction. That we thought, and I think the only way we can do that is using the debugger API, which would put that whole tab in debugger mode. So we're not exactly sure if there's any other way that Chrome lets us capture the JavaScript logs. Apart from that, I think most of the questions were covered here. Those were kind of the main areas that they had.
So in some instances where you have like cross-site scripting that fits into a certain context, you might need the response. How are you guys planning to get past to get the response data eventually?
So the main thing is, since all this can be forged, it's on the client side, and if the bug bounty, we don't want to trust this as a main source. We want to use this and then replay it back. Since the bug bounty hunter is giving you the video as a security engineer, you want to do some kind of vetting on the video itself. So even if you get the response back, we do not know if it's a correct response or it's a forged response. So we don't really care about the response part of it. We more really care about the request part and the URL part so that we can replay that and check if that's a valid bug or not. Yep.
Have you guys thought about creating kind of like a direct extension for Burp to import things easily? Is that in your future plans?
Yes, that is on our future plan. But right now we've just found this curl fix easier. But yeah, I don't think it's pretty hard. Like we just have to like.
We thought of it and then
yeah.
we're like, okay, this is going to be easy, and building a Chrome Burp will be good, but having curl pipe it through this kind of works. So.
Yeah, and then does it capture things like, for example, if I'm going and like disabling the Chrome XSS auditor, or if I am disabling like the CSP policy, or like basically like browser settings that may be necessary for me to be able to like repro a bug? Do you guys capture
This
that?
captures the network interactions directly. So the things that you have on the browser doesn't come through. I may be wrong on that, but that's what I assume. In the browser extension kind of captures directly the request and the response before it's sent out. So even if they have something on the browser extension which removes CSP headers, it doesn't.
Yeah, like given that you guys are already like injecting in the browser, that might be something that would be interesting to capture, because
Yeah, for sure.
it would affect being able to reproduce an XSS or something.
Yeah, for sure.
Thank you.
Great talk, first of all.
Thank you.
Second, if I have to slightly change the network communication, let's say change to a staging server, how do I do that if the file is embedded inside the video?
That's a really good question. I mean, as of now, we do not have any functionality which lets you modify.
Actually, that's a good feedback. It's pretty easy for us to get the JSON separately. I mean, we put all the effort into putting it into a video to make it less cumbersome. So we can open up the previous option we had of having them separate. And I think that would be pretty useful, because you have the whole network data in a JSON, and you could traverse it and use it to reproduce or like do whatever you want and manipulate it.
One other thing
yeah,
is,
we can do it. Actually.
Yeah, Chrome
It shouldn't be
62
a-
has support for HR files import, which was not there when we built it. So I think that's one of the things of exporting as a HR file and then maybe giving it to Chrome or something else. That would be something that we could add. It should not be much work because already network interactions are there.
Just wanted to make sure I understood this correctly. Is the preview tool that you showed us only for the person recording the video, or is having the browser extension sufficient to send somebody, like somebody I send the video to can just use the browser extension to view the video?
So the browser extension is enough for capturing, and even the browser extension has a previewer out there. So we can probably show you that later.
Yep.
Yeah. So this previewer, you can just get it right out of the extension, or you can download the code, like he showed before, and
Yep.
yeah. So you have it there, and you have it in the GitHub repo where you can just download it and use it on your local, host it on your local site, or you can go to our website. So there are like 3 options for this, and
Yeah. So if you are recording
you
it,
could just go to the
you
repo.
don't need. You just need
The
Chrome
extension.
The person receiving the video can just have the browser extension.
Yes.
Yep.
Okay.
They don't even need to have the browser extension. So yeah.
Yep.
Any other questions?
Okay.
Okay. Thank you all. Thank you for being here.
Thanks a lot.